Hi, Santiago here. Let's learn how to model initial geometry from Grasshopper while we learn modeling in Grasshopper for complete beginners. Let's do this. So, first of all, you will always have a final file with everything configured, but I recommend you to always do it step by step to understand what does every component do and understand also how one of it that goes wrong can affect all the process. So please always do it step by step. First of all, let's construct our construction point. Let's add the combination construct points and let's copy and paste it 4 more times. Then you can see that we have our points located in the 0, 0, 0 location. You can verify here that this is the value. So we can start with this one. Let's go to the next one and then add a number slider. Let's add from 0 to 20 and let's connect it with the x coordinate. You can see if we play the number slider that we're changing the width of our shape. What is going to be the width of our shape? Then for the third one, that is the one that is going to be here, we connect also this number slider of the x, but also we need to configure the height of what is going to be the square of the box. So let's add another one and let's place it connected to the z coordinate. Now let's start to modify it and we can see that we are creating the shape of our house. After that, we need to put the crest, the top of our roof. In this case, this is going to have an additional height and also it's going to be in the middle of this distance. So let's add a division component. Let's connect the number slider of the width and let's divide it with the set data item to 2. So we are dividing this information by 2. We can connect this to the x component and we can see that it's well located. And now we need to add an addition. Here we're going to add this number, that is the one that configures the square of our house, and another one that is going to be the height of the roof. Now let's connect it to the set, and you can see that we are now nearly to finish the shape of our house. Now, finally, we just need one that needs only the height with the set coordinate. So let's connect it, and that's it. We have all this shape. Taking count that we have placed the points with the steps that the polyline is going to take to make the shape. So now let's add a polyline and let's connect one by one with the order we already made the vertices. Don't forget always to press and shift to add the values, because if you just place it once, it is going to replace the last one that it was placed. You can see here that we are near to end. We can create another construct point or just configuring the closed to Boolean true. We are telling to the component that we want to have a closed polyline. Here we have it. After that, we place an extrude component. We connect the polyline with the base. Let's add a direction that is going to be a y direction and also a number slider. We can just copy the ones that we already worked. And here you have it. After that, we add a cap holes and we have a closed BRep. You can hide the other things just to have more clear information of what you are modeling. After that, we're going to make a grid structure. For that, we're not going to put a center box and 3 sliders. The sliders can have only just one point. Let's copy it 3 times. Let's put also a construct point and let's connect the 3 sliders. Oh, I've just realized that we just need one slider because this square, it's a proportional square. And also put the 3 sliders on the X, Y, and Z input of center box as also in construct point. And after that, you're going to put the base of the center box on the construct point. Here you can see we have our square inside the model we are shaping, and we need now to make the grid of our structure. Let's add a BRep wireframe. So here we're just taking the edges of the element and then box array. Now let's connect the wireframe output with the geometry input. Let's connect also the box output to the cell input. You can see that we are not now seeing the grid. And now let's copy and paste the sliders that we already configured and place it in the X, Y, and Z count. Let's have a slow value. Let's connect them. You can see now that the grid is taking shape. It started to evolve inside the house. Let's configure it to have a little bit outside of it. Perfect. This is now really close to the shape that we are shaping right now. After that, we are going to eliminate some duplicate lines that are going to be output in this geometry. Why? Because we have box over another box. So when they collide, the two vertices of the two boxes are going to be produced, are going to be created. And this is going to be a problem in the final model. So we need to remove duplicated lines. This is a kangaroo component that is included in Rhino 7 and Rhino 8. And it's really, really useful. After that, we're going to trim with BRep that is going to make the operation where the shape we have created is going to trim the structure we have also created. Let's add the component. Let's select the curve that are the unique lines and the BRep that is the house. And if you select it, you're not going to see anything because it's showing both of the products. It's showing the inside and the outside. If you want to check it, just add a curve component and let's connect just the inside output. You can see right now, if we hide the other ones, that we have the shape of our house. It's amazing. Finally, we need to create the structure. So let's put a pipe component. Finally, let's add a number slider from 0 to 1.00. We are adding 2 decimals because in the radius of the element are going to be required. So let's connect the radius. Maybe let's put it in 0.55 and the curve. Let's see what does it make. Here we have it. Nice. Let's make it maybe 0.2. Perfect. I think this one looks great. Finally, we add cap holes because these pipes aren't closed. We connect the BRep. It's going to take some time, as always. Perfect. Sorry, because it was a little crashed the computer. It crashed the computer a little bit, but we're fine right now. We've made our cap holes, and finally, we can make a 3D model of it. We just right-click over it. We click on bake. We click on group. Yes, please. Perfect. We have the model in Rhino. We just click here in Boolean Union. We click it, and it's going to try to join every pipe that we have modeled. This is required because when you want to export it as a 3D printable file, it requires everything to be joined. If you have separated, you're going to have a lot of mistakes that the slicer is going to make when it tries to slice it. So try to make the Boolean Union. Just after that, just clicking export, save as type as an STL, the file name it, and then take it to your 3D printer. And don't forget that you will have to put a structural reinforce in these corners that are going to have this overhang. I think that the correct way to print it is as shown, with the plate in the bottom part of the model, and our part worked perfectly fine. Here you have an example of this model with a little more of height, but it worked perfectly fine. Maybe we have a little mistakes here because it's a little bit small, so the 3D printer make a lot of effort to be exact, but it's beautiful, and it shows us how useful can be parametric design with Grasshopper to help us architects to achieve our ideas. So I hope you have learned a lot in this exercise, and I will see you on the next video.